next way we're going to solve a system is by elimination. This is probably my favorite way. It's the quickest way, especially if you don't have to multiply, which we'll get into tomorrow. But substitution can take some work, especially if it's not equal to x or equal to y. So elimination should be our quickest route for the most part, depending on how they're written. And what we want to do is we want to either eliminate the x or the y to solve for the other one. And I'll show you what you mean. And we do that by either adding or subtracting. So elimination by addition or subtraction. We either add or subtract the two equations in order to eliminate one or the other. So if I look at my equation down here, my system, 2x plus y equals 18 and x minus y equals 12. Well, if I look at it, I want to look at either the x's or the y's to decide which one I can eliminate. Well, if I look here, I have a 2x and an x, so they're different values of x. Or over on the next one for my y's, I have, each of them are one y, right? One's a plus y, one's a minus y. Well, if I think about it, if I added out a plus y and a negative y, a minus y, if I added those together, don't they eliminate each other, right? They would cancel. So if I would add these two equations, the y's would eliminate each other, right? Because a y plus a negative y cancel each other. Well, then I just add everything else. 2x plus an x is a 3x. Bring my equal sign down. And 18 plus 12 is 30. And now I have an equation to solve for x. And I solve for x, and I have to plug back in and find y. And we'll do that here in just a second. Whereas if I look at this other one, I have the exact same thing, except I have a plus y instead of a minus y. So I don't want to add here. If I added, I'd get 3x plus 2y equals 30. And that doesn't help me at all. I still have two variables in. I need to get down to one variable in order to solve. So instead of adding the equations, I would subtract these two equations, because a y minus a y is 0, right? If I took a y minus a y, so I subtract the two equations instead. So in this case, I get 2x minus x, so I just think 2x minus x gives me x. Then I take a y minus a y, which is gone, right? They cancel, and 18 minus 12, which is 6, and I bring my equal sign down. So that's the only difference. We're just subtracting instead of adding. And really, I could think of it as adding by the opposite, right? If I change this to addition, I really just change the sign of all these terms, add by the opposite. I get the exact same thing. Okay, so you either add or subtract the equations in order to eliminate either the x or the y. And then you can go through and solve. And we'll show you how you finish these out. So if I take a look at number 1 here. Solve this system by elimination. Well, look, which one should I eliminate? The x's or the y's? Well, probably the x's, right? Because one's a negative 3 and one's a positive 3. Okay, I don't want to do the y's. That have to multiply, and we're not into that yet. So we're going to eliminate the x's. Well, do I want to add these two equations or subtract them? Well, one's a negative and one's a positive, so I want to add these two equations in order to cancel my x's, to eliminate my x's. So I'm going to add both equations, negative 3x and a 3x, eliminate each other. 4y plus a negative 6y leaves me with negative 2y. Bring my equal sign down, and 12 plus 18 gives me 30. And now to finish my system, to finish solving this guy, I got to solve for y, so I divide by negative 2, which gives me y equals negative 15. So that's part of my answer. I know that the y is negative 15. Remember, all of our solutions are an ordered pair. And now I got to plug back in and solve for x. So I can plug into either equation. And in this case, I'm going to plug it into this second equation just because I'm going to end up with a negative times a negative. And I'll show you why that is. So I'm going to plug it into this second equation. So I got 3x minus 6y. Well, I said y was negative 15. So I'm going to put that in parentheses. Equals 18. And then simplify. So I bring down my 3x. Well, negative 6 times negative 15 gives me what? A positive 90 equals 18. And that's why I plugged it in there instead of the top one. I like to deal with positives. So now I just solve. So I subtract 90 from both sides. And I get 3x, that's gone, equals negative 72. And divide by 3. 3's cancel. We're left with x equals negative, what? 2, 4, negative 24. So that's my x value, negative 24. So there's my solution. The ordered pair, negative 24, negative 15. And if I would go back and plug that ordered pair into both equations here, it would work, it would make sense. So you can check if you want, you don't have to check. So the goal is eliminate either the x or the y, solve for that one, and plug back in and solve for the other. How about this one? Well, I could go both ways with this, right? If I would subtract, my x's would cancel, right? A 4x minus a 4x is gone. And then I could subtract the rest of the way through. If I would add, the 2y plus the negative 2y would cancel the y's, wouldn't it? So for me, I don't like to confuse myself. So subtracting gets a little confusing. So instead, let's do it both ways. Let's just take a look at both ways. 4x plus 2y equals 28. 4x minus 2y equals 18. So let's add this first one. So here, 4x plus 4x is 8x. 2y plus a negative 2y is gone. Bring my equal sign down, and then we're left with 46, right? 28 plus 18. And then I can solve for x over here. Divide by 8, and x equals 6. If I want the other route and subtract it, which this might actually save me some time. If I subtract it, well, now my 4x minus a 4x, that's gone. 2y minus a negative 2y. That's where it gets a little confusing. So what I like to do is let's just look. So 2y, I'm going to write this over here, minus a negative 2y. That's really plus a positive 2y, isn't it? Add by the opposite. So that's going to give me a 4y. And 28 minus 18 is 10. So sometimes what I'll do is I'll just add by the opposite. I'll change this to addition, and I'll just change the sign of all my terms. I'll add by the opposite. That helps me to see. I like to get it to adding anyway. So the x is still canceled. 2y plus a 2y is 4y. And 28 and a negative 18 is 10. So that works. And then finish solving, divide by 4. Divided by 4, and y equals 2.5. Well, I don't even have to plug back in and solve for the other because I just solved for x and for y. So I can put my ordered pair, 6 and 2.5. Okay, cool. So I could have just done a one route and then plugged back in and solved for the other one. Or I just did both. I could eliminate both of them. So I just set up two different systems there to solve. Okay, you might need to write your system depending on what is said. So if I look here, 4 times one number minus 3 times another number is 12. Then I got 2 times the first number added to 3 times the second number is 6. Find the numbers. Well, I need to give variables. Instead of x and y, since I've been doing x and y, I'm going to use different letters. I'm going to go 4 times one number, I'm going to call n, minus 3 times another number, I'm going to call m. So the first number I'm going with n, second number I'm going with m. So 4 times one number, so 4n, minus 3 times another number, 3m, is 12. There's my first equation. And then my second one, I got 2 times the first number, added to 3 times the second, is 6. So there's my system. So now I'm going to decide, should I add these or subtract these two equations? Well, I want to add to cancel my m's, right? Because I got a negative 3m and a positive 3m. So if I add them, they cancel. So 4n plus 2n is 6n. These cancel each other. Bring my equal sign down. 12 plus 6 is 18. And divide by 6. And we end up with 3. N is 3. Well, I got to plug back in to solve for m. So I'm going to go ahead and plug this into my second equation. Doesn't matter which one. And we'll bring this over to the right side here. So 2n, which I said is 3, plus 3m equals 6. Just bringing that over, just putting in 3 for n. And now we solve. So 6 plus 3m equals 6. Subtract my 6 from both sides. And we're left with 3m equals 0. Well, divide by 3, m equals 0. And I could go back and check both equations, and they both work out. So I'd say the first number is 3. I can put this in an ordered pair. First number is 3. Second number is 0. Just get used to putting them in ordered pairs. I don't have to. I could say the first number is 3, second number is 0. Or